For part B, we want to graph the polar equation theta is equal to pi over 6. We'll also change that into rectangular coordinates and then plot that on the rectangular system. If we just plot this in polar first, what we're going to do is we're going to try to draw all the points that have an angle of pi over 6, and the radius does not matter. So my first point could be 0, 0, and my next point could be 1 comma pi over 6, and so on and so forth. All of these points have an angle of pi over 6. And if we continue in the negative direction, when r is negative, all of these points will wind up lining up in a straight line. So they'll look just like this. If I switch to rectangular, what I'm going to have to do is I'll have to take the tangent of each side. Oops, it should be an equal sign. And the tangent of theta is y over x, and that'll get us into rectangular. The tangent of pi over 6 happens to be actually root 3 over 3. And if we multiply by x on each side, we wind up with root 3 over 3 times x. Now, root 3 over 3 is about 0.6, or we could even say that's about 3 over 5 if we're going to try to do some slope work with this. So we also know that the y-intercept is 0, 0. We could go up 3, right 5. 1, 2, 3, 4, 5, got it. And then 1, 2, 3, and then over 5 would be right here. So when we draw this, we're going to get the same line that we had on the red graph or the polar graph, and that actually should be the case.